Hello everyone. So in this video, I'm going to show you some multiplication tricks. So these tricks will help you do multiplications very fast, and sometimes you can do it even in your mind without needing any pen and paper. Let me give you an example. So here I have two-digit numbers. The tens place is the same, 6 and 6. The units place add up to 10. 8 plus 2 is 10. So in this case, you multiply 6 with the next integer, that is 7. So 6 times 7 is 42, and then multiply the units placed together. 8 times 2 is 16. That's it. So this is the result. As you can see, this can be very fast, but there are some edge cases where also it is very easy to make mistakes. For example, let's take a look at this. Here also the tens place is the same, and the units place add up to 10. 9 plus 1 is 10. So in this case, 3 times 4 is 12, and then 9 times 1 is 9, right? But this is not the correct answer. This is wrong. It should be 12 and then extra 0 and then 9. So we are not going to learn just the trick. I'll also explain why those tricks work so that you will avoid mistakes like this. All right. All right. So in this video, I'm going to show you how to multiply any two-digit numbers and then square any two-digit numbers, square any three-digit numbers. So multiplication of two numbers where the tens place is the same, units place add up to 10, and then square any two-digit number that ends with 5, and then multiply two-digit numbers where the tens place is the same but the units place do not add up to 10, and then we will extend this to decimals. Before we discuss these tricks, I must remind you about two multiplication facts because that forms the basis for most of the multiplication tricks that you will see, and it will also help you avoid mistakes like this. Even before we talk about the multiplication facts, let me lay down some basics here. Let a and b be a single digit integer and c and n be any positive integers. In that case, a times b may have one or two digits, very trivial. 2 times a times b may have 1, 2 or 3 digits, again very trivial. If we see a number like c times 10 power n, the rightmost digit of c is placed right after n places from the right. Let me explain this with an example. Let's say we have something like this plus this plus this. Here this is, let's say c, some integer times 10 to the power n, n is 3 here. Now this uh, computes to 72 here. 72 times 10 power 3. So this 3 means 3 zeros, right? So these 3 spots, they are zeros. We omit that for convenience, and then start writing 2. This 2 goes here. I put a pin here, means the 2 is kind of anchored there, and then 7 goes next to that, so on and so forth. Let's say there was 5 here, number 5, then 5 would go here, so on and so forth. Similarly, here another example, 7 times 10, so it has 1 0, so I leave one spot and then start writing the 7 there, right? If there was another number here, that would go next, and then I add it up, I get this. All right, now so that's this. And then place value model. In algebra, typically when I write a b, it implies a times b. However, I use the over bar to represent digits. So this means not a bar times b bar. This means, a bar is in the tens place, so this is 10 times a. B bar is in the unit place, so it's just b. Just as an example, 72 means 7 is in the tens place, so that is 10 times 7, and then 2 is in the unit place, so 7 times 2, right? So 72 has, in terms of place value model, this is how we write. So this is something to keep in mind. All right, now regarding the multiplication facts, the first has to do with number of digits. Let's say I have two integers, so this has m digits, 1 2 3 4 5 6. M is equal to 6 in this case, and here let's say n digits, which is equal to 3 in this case. Now the question is, how many digits the product will have. And can we figure that out without actually multiplying? I have the derivation is, proof is very simple, so I'm not going to go through it here. Let me know if there is any doubts in the comment section. So it will have a minimum of m plus n minus 1 or maximum of m plus n digits. We typically mark m plus n spots, reserve m plus n spots for the product. The second fact has to do with place of influence. Let's say I have two integers. So when we multiply, the conventional way is each digit of this multiplies with each digit of that, right? So the question is, when 6 multiplies with 2, what will be the place of influence? So the 2 has a place value of 2 times 10 power 3. Similarly, 6 here has a place value of 6 times 10 power 1. If we do the multiplication, it comes out to be 12 times 10 to the power 3 plus 1. And the 3 has to do with how many digits are to the right of 2, and the 1 has to do with how many digits are to the right of 6 here, right? So 3 plus 1 is 4, so we leave 4 spots here and then start writing the result there. So these are single digit, and as we saw before, the result will be either a 1 or 2 digits. If it is 1 digit, it will go here. If it is 2 digit, the unit will go here and the other digit will go there, right? All right, moving on to the first trick, multiply any two-digit numbers. Here is an example. So from the first multiplication fact, I know that there will be 2 plus 2, 4 digits. Then what I do is multiply the 10 places, that is 4 times 3 is 12, place that here, and then the units places, 5 times 2 is 10, that goes next to it, and then the unit and 10 places, so this is 15, and then this 4 times 2 is 8, together is 23, that goes starting from the tens places, and then add it up to get this. If this sum was a 3-digit number, the other digit will go here, right? Now, where I place this is based on the second multiplication fact, the place of influence, but you can also prove it independently. So I can represent the 2-digit numbers like this and expand this in terms of place value like so, and then using the distributive property, this is what I get. And as you can see, the coefficient of AC is 100, meaning the AC goes after 2 spots, and similarly for the other terms. All right, let's do some examples. 12 times 24, so I reserve 4 spots. 1 times 2 is 2, goes here. 2 times 4 is 8, goes here. 2 times 2 is 4, plus 1 times 4 is 4, so this is 8, that goes here. 288 is the answer. Here I reserve 4 spots. 1 times 3 is 3, goes here. 2 times 5 is 10, goes here. 2 times 3 is 6, plus 1 times 5 is 5. 6, 5 is 11. Add 11 there. So 0, 2, 4. This is a 4. 420 is the answer. Here again 4 spots. 8 times 6 is 48, and then 5 times 9 is 45, and then this is 30, this is 72, so together is 102, 102. This is 5, 6, 8, 5. This is the final answer. And here again 1, 2, 3, 4. 9 times 5 is 45. 0 times 2 is 0. 0 times 5 is 0. 9 times 2 is 18. So this is 18. 18. 0, 8, 6, 4. This is the final answer. This you can also verify because there is a 0, is easy to multiply, right? So 9 times 2 is 18. 18, 1 carry over. 9 times 5 is 45, plus 1, 46, and then 0, right? Next trick is square of any 2-digit number. So I have an example here. So square this is 16, goes here. Square of this is 9, that goes here. and then 2 times a times v, that is 24 goes here, add it up, this is what we get. Proof is actually fairly simple. I have given it here, so I'll not explain it. If there is any doubt, let me know in the comment and I will explain more. Let's do some examples. So again, these are 4 spots. 1 square is 1, 2 square is 4, 2 times 1 times 2 is 4. This is the final result. These are 4 spots. 3 square is 9, 6 square is 36, 2 times 3 is 6 times 6 is 36. 36, add it here, 6, 9, 12. This is the final result. 82 square is, these are 4 spots. 2 square is 4, 8 square is 64, 2 times 8 is 16, times 2 is 32. So this is 4, 2, 7, 6, right? These are 4 spots. 5 square is 25, 0 square is 0, 2 times 5 times 0 is 0, right? So this is the result. You can also verify because this is a simple square, right? 5 times 5 is 25, 100. So again, 4 spots, 7 square is 49, 5 square is 25, 2 times 5 is 10, times 7 is 70. So this is 5, 2, 6, 5. Final result. There is another trick for this that is coming up actually, so very easy to multiply. This one, this is 49, 64, 2 times 8 is 16, time 7 times 8 is 56, times 2 is 112. So this is going to be 8, 8, 0, 6, 6, 6088. 6088. Next trick, square up any 3-digit numbers. So in this case, 3 plus 3, there will be 6 spots I have reserved here. So a square is 1, that goes here. 4 square is 16, that goes next. 5 square is 25, that goes next. Then 2ab is 8, that goes here. 2bc is 40, that goes next. And then 2ac is 10, that goes here. You add it up, you get this result. Proof is fairly simple. If there are any questions, let me know in the comment and I will be happy to explain. Let's do some examples. All right, 1, 2, 3, 4, 5, 6. 1 square is 1, 2 square is 4, 2 square is 4, 2ab is 4, 2bc is 8, 2ac is 4. So this is going to be 4, 8, 8, 4, 1. So this is the final result. So again, 6 spot, 1, 2, 3, 4, 5, 6. 3 square is 9, 0 square is 0, 6 square is 36, 2ab is 0, 2bc is 0, 2ca is 6 times 3 is 18, times 2 is 36. So this is 6, 3, 6, 3, 9. Right here again, 6 spot, 1, 2, 3, 4, 5, 6. 4 square is 16, 5 square is 25, 2 square is 4, 2 times 4 times 5 is going to be 5 times 2 is 10, times 4 is 40, and then 2 times 5 is 10, times 2 is 20. So that is this, and then 2 times 4 is 8, times 2 is 16. All right, so 4, 0, 3, 4, 0, 2. All right, 298 square is 1, 2, 3, 4, 5, 6. 2 square is 4, 9 square is 81, 8 square is 64. 2 times 9 times 2 is 36. Okay, 9 times 8 times 2, so 9 times 8 is 72, times 2 is 144. So it has to start from here, right? So right from here, 441, and then 2 times 8 is 16, times 2 is 32. So that goes here. So this is 4, 0, 5, 6, 7, 8, 14, 15, 16, 17, 18, 1, 5, 6, 7, 8, 8, 8, 8, 0, 4. Next trick is actually a rockstar trick. When it applies, it has to do with multiplying two-digit numbers such that the tens place are the same, in this case 6 and 6, and the units place they add up to 10. 8 plus 2 is 10. So in this case, first of all, two digit times two digits, so we reserve fourth spot, and then take the 10 digits, so that is 6 times the next integer, that is 7, so that is 6 times 7 is 42, that goes here, and multiply the two unit digits, 8 times 2 is 16, that goes here. The proof here is also actually not that difficult. Please let me know in the comment if there are any questions, and I'll try to help. Let's do some examples. Again, reserve four spot. So 7 times 8 is 56, 9 times 1 is 9, empty spot 0. Again, 1, 2, 3, 4. 2 times 3 is 6, 7 times 3 is 21. That's it. 1, 2, 3, 4. So 1 times 2 is 2, 9 times 1 is 9, 0 in the empty spot in between. 1, 2, 3, 4. 5 times 6 is 30, 7 times 3 is 21. That's it. So 75 square is what? 75 times 75. So this also matches the requirement, right? So unit digits is the same. Sorry, the tens digit is the same, and the unit digit they add up to 10, right? So in this case, 7 times 8 is 56, 5 times 5 is 25. Same here, 4, 9 times the next integer is 10, so there is 90. 5 times 5 is 25. Next trick, square two-digit numbers ending with 5. So this is a special case of the previous trick that we just saw. So 85 times 85. So here the tens digits are the same, and the unit digits they add up to 10, right? So we can apply the previous trick. So this is 8 times the next integer is 9. So that is 8 times 9 is 72, and then 25. 5 times 5 is 25. 4 spots, right? All right, so let's do some examples. 2, 3, 4. So 1 times the next integer is 2, so there is 2. 5 times 5 is 25. All right, so here 2 times 3 is 6, 25, and here 3 times the next integer is 4, so that is 12, 25, 2, 3, 4. 4 times next integer is 5, so that is 20. 5 times 5 is 25. 2, 3, 4. 5 times 6 is 30. 25. 9 times next integer is 10, that is so 90. 25. Our next trick is actually an extension of the previous trick. In this case, also tens place are the same, so this is the same, and the units place do not add up to 10. So these do not add up to 10. So can I try to split this such that, okay, let me write it down, or I can split any one 40 times. I want to split this number so that I can use one of the previous trick. So I'll write 49 as 48 plus 1. 48 because I have 42 here, so these two can add up to 10, right? So I know how to do this multiplication. So this is 4 times the next integer is 5, so that is 20, and 8 times 2 is 16, right? So this is this, and then I just add 42, right? So this is 8, 5, 0, 2. That's it. The next and the final trick for this video has to do with any of the tricks that we saw earlier, we can extend it to include decimals. For example, if you stare at this, 6 and 6 are the same, and 8 plus 2 is 10. So we can use one of the previous tricks. So 6 times the next integer is 7, so there is 42, right? And then 8 times 2 is 16. All right, this extra 0 I can put it here, and there are 1, 2, 3, and then decimal. So 1, 2, 3, that's it, right? So in this case, this can be 42 square. So 42 square is you know uh, 4 spots. So 4 square is 16, 2 square is 4, right? And then 2 times 4 is 8 times 2 is 16. That goes 16 here. 4, 6, 7, 1. And this extra 0 can go here, and then 2 spots for the decimal, 1, 2. That's it. All right. In real life, though, nobody is going to give you two numbers and say, hey, multiply these two numbers using this trick, right? So you will solve problems, and during solving a problem, you will encounter multiplications and different mathematical operations, and it is up to you to figure out quickly if you can apply a trick and what trick, right? And that comes with practice. So for you to practice, I have given you some problems here. Please make an attempt and let me know your answer in the comment section. I will actually do this and put the solution in the description of this video. Thank you so much.